So we can use charges to write formulae too. So for example, write the formula of lithium oxide. Lithium, the charge of lithium ions is Li plus and oxide O2 minus. How many pluses do we need to balance 1, 2 minus? And the answer is we need 2 of them. 2 pluses will balance 1, 2 minus. So 2 lithiums, 2 Li pluses balances perfectly 1, 2 minus. The formula is Li2O. Let's try another example. Iron 3 oxide. The iron has got a charge of 3 plus. The oxide ion has got a charge of 2 minus. So we have to look for a common multiple of these two, which would be 6. So we would use 2 times 3 pluses to make 6 plus, 3 times 2 minus to make 6 minus, and they would equal each other. So we need 2 of these, Fe2, and 3 of these, O3. Okay, there's a list of formulae that you should try to write using the previous methods, either valency or charges. You should be able to write the formulae of those compounds. Lithium oxide we've just done, so that's a revision for you. Sodium sulfide, Na plus, S2 minus, or sodium's got a valency of 1, sulfur's got a valency of 2. You can use either method to get to your answer. Have a go at those questions. Now, writing chemical equations. There are different types of equations you're going to have to be able to write. The one that you've seen probably the most throughout Key Stage 3 and in junior school is a word equation, which essentially is just the words of the chemical substances involved. Now you're going to start using symbol equations, often just called equations at IGCSE, which involve the symbols of the chemicals involved. And there's a new one called ionic equations, which just involve the ions of the chemicals involved. This is the one you've seen the most of, and for example, carbon plus oxygen gives carbon dioxide. Symbol equations. This is the most common at IGCSE, and you have to be able to write the chemical formulae of the substances involved. So, for example, if I'm reacting hydrochloric acid with sodium hydroxide, then I write the formulae of those two substances. I need to know the products, which will come with time, but acid plus alkali gives salt plus water. And then I need to think about balancing these equations. Now, if we look at the equation above, if we count what's on the left-hand side and what's on the right-hand side, you will see that everything balances. I've got 2 hydrogens here, and I've got 2 hydrogens here. 1 chlorine, 1 chlorine. 1 oxygen, 1 oxygen, 1 sodium, 1 sodium. So that's balanced. But you know that that's not always the case. So we have to follow some simple rules, simple guidelines to balance equations. The equations must have the same number and type of symbols on each side. You cannot destroy the elements involved or mass. So this is really the law of conservation of mass. And if you want to change the number of symbols on either side, you put large numbers in front of the formulae. You can't change the ratio within the formula itself. So here, if I want more sodium, I have to put a big number in front of the whole compound. And that big number, obviously, would distribute. So if I put a 2 here, I get 2 sodiums and 2 chlorides. It's very important that even before trying to balance an equation, we double check to make sure that we have the correct formulae. Okay, so when we write out the equation, we write the formulae of the chemicals involved, then it's very important we double check to make sure we've got the correct formula. Otherwise, we can't balance the equation. So let's have a look at an example. Magnesium oxide reacting with hydrochloric acid. Now you may remember that base plus acid gives salt plus water. So here, magnesium oxide, Mg2 plus O2 minus, so that's the correct formula, reacts with HCl, which is hydrochloric acid. It produces magnesium chloride. Now here we've got to be careful. Magnesium is Mg2 plus, but chloride is 1 minus. So we need 2 chlorides to balance the Mg2 plus. Look back at the techniques we used in previous slides. And the other product is water. So that's the equation, but it's not balanced yet. This is where we have to be very careful and make sure we balance carefully. We've got, on the left-hand side at the moment, we've got 1 magnesium, we've got 1 oxygen, 1 hydrogen, and 1 chloride. On the right-hand side, we've got 1 magnesium, 1 oxygen, 2 hydrogens, and 2 chlorides. So, we've got a problem. We need more chlorides on the left-hand side so that these two sides balance. The way to do that is to put a number in front of the hydrochloric acid. Now, if we need 2 of each of these, then it's clear that that number is going to have to be a 2. So now we've got 2 hydrogens, 2 chlorides, and everything balances out. Okay, balancing equations is not difficult, but you have to develop your own system of doing it. And after a while, it becomes very obvious to you, but at the beginning, it can be a little bit tricky. So just practice. Right, look at the pages indicated. It'll be page 52 and 53. Read through them and try the questions. One last thing before we finish is ionic equations. Ionic equations, they're the trickiest, but they're perhaps the most useful in chemistry because they only show the actual ions that take part in a chemical reaction. So let's do an example together. Barium chloride, which is a solution, aqueous, magnesium sulfate, again a solution, gives magnesium chloride, which is a solution, and barium sulfate, which is a solid. It's called a precipitate in chemistry, a precipitate. So when these things react, what's actually happening is the barium ions, the Ba2 plus ions, are meeting the sulfate ions, and when they meet in solution, they form a precipitate. They come out of solution and form a solid. So this is what's actually happening. The rest of the things that were there at the beginning just stay there. But this thing goes from being a solution to being a solid, to being a precipitate. And that's the key. That's the key in ionic equations. One little note, state symbols sometimes are required, and they can be a solid, liquid, gas, or aqueous if the substance is dissolved in water. Have a go at the questions on page 55, read the pages, and you're also ready for the end of chapter questions.